All right, now we're going to go and start hooking this stuff up. So now we're going to need a wrangle here. And this time we're going to keep it in points mode because this time we do want to affect all the points. And we can call this fall off. Okay, so we're going to want to query the setup so that we can get all of the matrices and information we need. So let's call this like get info. And we'll store these as variables. We don't need to store them as attributes here. So we have a matrix, which is going to be the fall off matrix. That's a detail attribute. We're going to bring in our input here. And then the name was fall off m, and then 0 for that last thing there. And let's just confirm that that's right. Fall off m, and then my m. All right, so I'm just going to copy and paste this. So my m is going to be equal to that coming in. And now we want the inner radius. Copy pasted too much. Let me just copy this here. And then outer. Okay, so we basically need to do a distance lookup. But the first thing we need to do is start dealing with our spaces. So I want my points here to be in world space because right now everything is in local space, meaning if I rotate and move my object around, these points, their at p value is not going to change at all. But I really need these things to be in world space. So we will start doing some of this stuff here. So convert p to world. And the way we do that, we're going to make a vector called my position and set that to our position attribute. And now we can convert this into a world space just by saying my p is times equal to my world matrix. And so far that works. We're going to deal with scaling and a few other things right now. I'm going to show you a little bit of the logic first, and then we'll get into dealing with the space transformations here. So let me just move down a little bit and give us some room here. So the way we're going to do a sphere is a simple distance lookup. So we're going to have a, let me put it up here. Let's put it here for variables. We'll have a variable called d, which is going to be for distance, and initially we'll set that to 0. Okay, so here we're going to do a sphere, and we'll say that d is equal to the distance of my p, and then a vector, which is going to be 0, 0, 0. It's going to be in the center here. Again, we're not going to deal with transformations just yet. We will get to that in just a second. So I'm going to put something here, vector, and I will just call this 0. All right. And now what we want to do is take that and start remapping it. So we will say that an attribute, which we're going to export, called effect, is going to be equal to fitting the distance as we go from inner to outer. We want to go from full value to no value. And then we're going to visualize that as well. So what I'm going to do here is go to our parameter interface, and I'm going to have a color ramp here, and I'm just going to put that right here. And we'll call this color ramp. Hit apply and accept. So what we'll say is where there's 0 strength, we'll make that red, and where there's full strength, we'll make it yellow. So it kind of matches what's happening down there. And we'll say at CD is going to be equal to the ramp, and that is called color ramp. And the lookup for that is going to be our effect. All right, so if I start playing with this, we should see that that works. All right, we'll save this and then we'll deal with the transformation. So I'm going to go back here. I'm going to save my subnet, save my file, and then we'll deal with transformation stuff. All right, so we'll go back in here and we'll go back to our fall off here. Now what we did is we took our position here and we converted it into a world position, but we need to do something else. We need to deal with what's happening with the transformation of the object up above, because you'll see right now, all we've done is we've said that we're comparing everything to a local position or global position of Z. So what we want to do is actually get the inverse position of this object. So we want to take whatever transformation would be required to move this all the way to 0 and reset all its rotations and basically invert that and apply that to here, so that we're kind of changing the lookup space that we're using. And it might seem a little silly now, but it's not too hard to do. So all we have to do is go back into our fall off, and we just take this position here where we're already converting to world, and I'm just going to make a little note so that it's clear what's going on, and we'll say multiply by inverse of fall off M. And basically now what we'll say is my P times equal to the invert of our fall off matrix. And you see what happens there is it just popped right over. Now this does a couple things for us, which is really good. It means that this can now be operating in a global space, but it also means that we can start to do things like scale this and start rotating it in space. And we'll see that this adapts automatically, as well as, because this is in global space too, is I can start parenting this object. That was weird. What just happened there? Looks like my viewport's stuck. Let's try a new scene view. All right, there we go. So this is now in a global space where I can be moving this around, and it's going to pass through there too. And again, this can be parented. Your controller can be parented to whatever you want it to be parented to. So it actually can now become part of a rig that you can move around and really have something that works pretty well. All right, so that works pretty well. Now we'll go ahead and we will do the box for this one. So we'll just go back in here and we'll save this and save our file, and then we'll come right back and do the box math.